All right, so here we're supposed to rationalize the denominator again and assume all variables represent positive real numbers and the denominator is not zero. All right, so looking here, what we need to do, this is kind of like the one where we did, what was it, the c over 27, and we want the square root of it. We had to think of that as the square root of 9 times the square root of 3. And so to get this to be no radicals in the denominator, we had to multiply by the square root of 3 because then we had 3 times 3 eventually. Okay, so now we have to think about this one. Well, now we need the seventh root of this. So we have only two y's. So how many we need to get this to be a whole number? Well, we need to have five more because this is y squared. And so if we have y to the fifth, then when we take the seventh root of that, that's going to be seven of them. And so the seventh root of y to the seventh is just y. So that means we have to multiply by what? Well, we need to multiply by the seventh root of y to the fifth, because when we multiply that times that, we'll get this, and that becomes this, and that gives us y. Now, if we do it there, guess what? We have to do it up here as well. Well, that makes it easy. We just take 8 times this, and we get 8, and then we have the seventh root of y to the fifth. Well, by design, we said that when we multiply all that together, we're just going to get y in the denominator, and so that's going to be our solution. So that's what we would stop with, and that would be how we get there. We have to think about how many y's there are to start with, how many we need to have, so we have to have five more here, and so then we multiply it by y to the fifth, the seventh root of that. We have to do it in the numerator, and then we end up with our solution. All right, let's stop there and we'll come back for some more.